Okay, this is probability review part 1, and this will be classic probability, and this will be video number 3. So first thing I need you to remember is the general addition rule, which is the probability of A union B equals the probability of A plus the probability of B minus the intersection. Please remember U means union or summation, and the way we phrase it is we might say A or B, as in here, or we may say A or B or both, all right? So all of these, this union means this, or means this, summation means this, and we can also say A or B or both. This is the intersection sign. And we also use the word and the way I remember that is, and it looks like it has an intersection sign in it. I should say this usually means plus, all right? The union usually means plus, so summation. Both this, and it also means both. Please know this is a joint probability. I shouldn't say condition. Let's scratch out that word and let's just say it's a joint probability. Mutually exclusive, the events cannot occur at the same time. The intersection is 0. So if I was drawing a Venn diagram for mutually exclusive events, there's no overlap, all right? There's no overlap. Now, independence. If independence, then the intersection will be A times B, and there will be an intersection, A times B. And there'll be, so if A times B equals the intersection, then we're good. Another thing that you can also say is the probability of A given B equals the probability of A. This will also be true, which means the probability of A and B over B equals A, and you'll need to know these. So I would highly recommend that you memorize all of it. This is known as the multiplication rule, and these are tests for independence right here. Every single one of these can be used as a test for independence. So please, please, please memorize these. This, I believe, will be on your formula chart, but I still recommend that you memorize it because it's used every single test. So you should know it as opposed to have to look it up because you're going to be short on time. Remember, events can be neither mutually exclusive nor independent. In other words, you don't have to be mutually exclusive and you don't have to be independent. You can be either one or the other. You cannot be both, and you don't have to be either. You don't have to be mutually exclusive, and you don't have to be independent. All right. Also remember, if the events are independent, the bar segments of a segmented bar chart are the same, as all proportions must be the same. Remember, if they're independent, the proportions are the same. So, hypothetical records indicate that the probability that a freshman in a high school has maturity issues or family issues is 0.71. The probability that a freshman has maturity issues is 0.48. We also know that the chance of freshmen having family issues is 0.34. What's the probability they have both maturity and family issues? So this sounds like this is going to be probability of A plus the probability of B minus the probability of A and B equals the probability of A union B. And so we can probably make it easier for ourselves by putting it in terms of this problem. So the probability of family issues union the probability of maturity issues equals the probability of family plus the probability of maturity minus the probability of family and maturity. And by the way, you will need to write down the formula. You can write it like this or like this, but one of those places you're going to have to show. So the probability that they have maturity issues or family issues is 0.71. I see the word or, I think union, I'm thinking this is 0.71. The probability a freshman has maturity issues, 0.48. We also know the chance a freshman has family issues is 0.34. And I'm just going to put an X because that's what I'm looking for. All right. And this is both, and both usually means intersection. Notice I'm using the word usually. These aren't exacts. So when I do this, I go, well, 0.34 plus 0.48. So I end up with 0.71 equals 0.82 minus x. Subtract 0.82, and I end up getting negative 0.11 equals negative x. So make both of them positive. The answer to my question is 0.11. There's a 0.11 probability. All right. The next question. Probability of A equals 0.2. The probability of B equals 0.1. What is the probability of A union B if A and B are independent? So they're asking for A union B, so I probably should write that formula. So probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. But they told me something here. They told me that A and B are independent. Well, if they're independent, the probability of A and B equals the probability of A times the probability of B. So I can plug this in. I can substitute. There's a good math word right here. And I end up getting the probability of A union B equals the probability of A plus the probability of B minus the probability of A times the probability of B. Now, the only reason I was able to do that is because they were told me they were independent. If they don't tell me they're independent, I can't do that. I can only do that when it's independent. So I'm going to start plugging in my values, and I have 0.2 plus 0.1 minus 0.2 times 0.1. So we're ready to solve at this point. 0.2 plus 0.1 minus 0.2 times 0.1, and we end up getting 0.028 or 0.28. So the probability of A union B equals 0.28, and there's our answer. All right. Suppose the probability of X equals 0.25 and the probability of Y equals 0.40. If the probability X given Y equals 0.2, what is the probability of Y given X? So what we want to know is what's the probability of Y given X? Well, first off, what is that? Well, the probability of Y given X, and by the way, that line just means given, equals the probability of Y intersect X over, that should have been X, probability of Y given X over the probability of X. Whatever is here is going to go here. Well, what do we know? Well, we know the probability of X is 0.25. But in this case, I don't know the numerator. All right. I don't know the numerator, and this is what I was looking for over here. So I'm kind of stuck for a moment. But let's see what happens if I work with, they give me this information. Well, what is that information? Well, the probability of X given Y equals the probability of the intersection. So the probability of X intersect Y over the probability of Y. Now hold on for just a moment. This and this, even though I swapped the order, it's still the intersection. They mean the same thing. So these two things right here are equal. Really important to know that. So they told me that X intersect Y is 0.2. So that we have this. We know this is 0.2. We know the probability of Y is 0.40. That's right here, although I kind of covered it up. But I don't know the probability of the intersection. But I can solve for it. And so when I solve for it, I find the probability of that intersection, the probability, and I guess I should probably write it out, the probability of X and Y. So that's going to be 0.2 times 0.4 equals 0.08. So the probability of X and Y equals 0.08. Wait a second. I now have my missing numerator. All right, because that's what I was missing here. So I was like, oh, I can put this over 0.08. I mean 0.08 over that. So that means I can take 0.08 and divide it by that 0.25, and I get 0.32, and that's my answer. Now, I recognize this is a puzzle, and I have to admit, with all of these problems, what you need to do is after you watch the video and try them out, you need to try them out later by yourself and keep doing them until they stick in your head. Once they've stuck in your head, you'll be able to do these problems and you'll be great on the test. The way you learn it is to practice them, and you can practice the same problem over and over again until it sticks, okay? So, and honestly, practice is going to be up to you guys. You're going to need to do this on your own. Given the probabilities A equals 0.4 and A union B 0.6, what's the probability of B if A and B are mutually exclusive? All right, so they want to know mutually exclusive. Well, that's easy. Because remember, well, first off, they're giving us this. And anytime you give me this, I'm writing this formula. Probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. Well, they're telling me that this is 0.6, A is 0.4, B is what I'm looking for, so I'm just going to put a B there, minus my intersection, but they said that they're mutually exclusive. Well, if they're mutually exclusive, there's no overlap, and this equals 0. So this is really easy. In this case, we're just going to subtract 0.2 equals B. Simple, simple. All right. Over here, I'm going to probably run out of room here, but we still have this formula. All right. But they say they are independent. What do we do if they're independent? Well, please remember that if they're independent, the probability of A and B equals the probability of A times the probability of B. So I can take this that I have right here and substitute in, and then we're going to get to do a little bit of algebra. So I'm going to substitute this in. So I'm going to have probability of A union B equals the probability of A times the probability, it's not times, plus the probability of B minus, where I substitute in, the probability of A times the probability of B. And this is my substitution right here. This part that right there. Well, we know that A union B is 0.6. Probability of A we know to be 0.4. B is not what we're looking for. We don't know what it is. Minus, and we know that this is going to, the probability of A is 0.4 minus 0.4 times B. All right, we still don't know that B right there, and so there it is. Well, I can subtract this and I get 0.2. So 0.2 equals 1B minus 0.4B. Well, 1B minus 0.4B is 0.6B. So I end up with 0.2 equals 0.6B. And I'm going to write that over here, that same thing. So 0.2, change the colors, 0.2 equals 0.6B. Divide both sides by 0.6. And B equals 1/3 or 0.333 if you prefer. Okay? Hard problem, practice it. You can do it. I know you can, but you're going to have to practice it. All right, given that the probability of E equals 0.32, F is 0.15, and E union is F, are they independent? Well, once again, they've given me this formula, so consequently given me this, so I'm going to write my formula. So the probability of E union F equals the probability of E plus the probability of F minus the probability of E and F. So let's plug in and see what we have, and we'll check things out. So, and this is always just a starting point, is right. I see this, I'm going to write this formula, I'm going to plug in what I have. So this is 0.422 equals 0.32 plus 0.15 minus, and I'm just going to use E and F. I'm just going to get rid of the probability sign for the time being, just to make my life a little easier. Okay, so what's 0.32 plus 0.15? 0.32 plus 0.15. All right, and I'm going to subtract it from this. So I'm going to have 0.422 minus this, and I'm going to have negative 0.048 equals negative E and F. So I can just make those positive. So that's my intersection. It's like, oh, wait a second, I remember something. If they're independent, the probability of E times the probability of F will equal the probability of E and F. Well, we know E, we know F, and we now know E and F is 0.048. So let's see if this is true. 0.32 times 0.15, they're equal. So 0.048 equals 0.048. Therefore, they are independent, right? Therefore, they are independent. Now, if they did not equal, they would not be independent. All right. So because they're equal, they're independent. All right. Last problem here. Each person in a random sample of adults indicated his or her favorite color. The results shown in the table are reported by age group of the respondents. If choice of color is independent of age group, in other words, pretend. So if choice of color is independent of age group, how would you calculate the expected number of respondents who are over the age of 50 and prefer blue? So over the age of 50, prefer blue. I'm looking at this and I'm going to go, all right, 75 times 92 over my total. That would be my work shown. Okay. So I would do that and I would go, okay, 75 times 92 divided by 314. And I end up getting 21.97. This is what I would expect. That's not what I have. So not independent. Another way to check independence. So this is what it would be. These are my expected values. So that expected value equals 21.97. If I wanted to check independence, I'd probably do this. I'd probably go 75 times 314 times 92 over 314 and check to see if it equals the intersection, which is 35 over 314. And what I'm doing here is a probability of A times a probability of B equals a probability of A and B if they are independent. So let's do this real quickly. 75 divided by 314 times 92 divided by 314, and we end up getting 0.0699. And here we went 35 divided by 314. We're like, oh, no, these are not equal. Therefore, not independent. Now, it didn't ask me if they were independent. What it asked me to find was the expected value, which was this. And I could look at the expected value and go, you know what, it's not the same, so not independent. It's not really close. All right, thank you.